Welcome to this Bishop Grotesque guest lecture. My name is Dr. Derwin Gregory, and for the next half an hour I will be discussing the archaeology of the Cold War. Between 1945 and the fall of the Berlin Wall in 1989, the world was split between the political ideologies of capitalism and Soviet bloc communism. The military standoff between the United States of America and the Soviet Union shaped the history of the second half of the 20th century. Archaeology is a study of human history through artifacts and physical remains, and as such, the Cold War, with its bunkers, missile silos, airfields and other installations, has an archaeological footprint. In this lecture, I will introduce you to some of the buildings and structures developed during the Cold War and built in the UK. The learning outcomes for this lecture include being able to recognise Cold War structures, to distinguish between different types of Cold War structures, and to assess the impact changing policies and technology had on the archaeology of the Cold War. One of the defining features of the Cold War was a stockpiling by both East and West of ever larger and more advanced nuclear arsenals. Britain's first nuclear bomb was modelled on the wartime implosion device Fat Man that had been dropped on Nagasaki in August 1945. Work on the warhead and the bomb casings was the responsibility of the Royal Aircraft Establishment located in Farnborough, which worked in association with private industry. In the 1950s, flight tests on the shape of a bomb were conducted at Orford Ness in Suffolk. Unfortunately, during those early tests, bombs which were dropped from high-speed aircraft gained lift and re-entered the bomb bay. The engineers had to quickly redesign the bomb to stop this from occurring again. Before a nuclear device could be deployed, its design needed to be rigorously tested. In 1954, it was decided that facilities were needed to experiment on the nuclear warheads under realistic conditions, and Orford Ness was selected to host these tests. At the height of activity at Orford Ness, the facility was equipped with 5 laboratories designed to shake the bombs to replicate the conditions they would experience whilst in flight. Laboratories were also conducted to see if the bomb could withstand changes in pressure and temperature. With the introduction of the Polaris missile system, the decision was taken to close the laboratories at Orford Ness, and the facility eventually closed its doors in October 1971. Britain's first operational nuclear bomb was called Blue Danube, for which 2 specialised storage and maintenance facilities were built. One of these was located at Barnham in Suffolk, and the other at Foldingworth in Lincolnshire. Both sites were a long way from the nearest airfields, and they were designed as service bombs for a number of squadrons. To ensure there was no accidental nuclear explosion at these facilities, the nuclear bombs were stored disassembled. The non-nuclear components were stored in these buildings, highlighted by the arrows, whilst the nuclear fissile cores were kept in a number of small structures spread around the wider complex. The Blue Danube was carried by the UK's nuclear airborne deterrent, which was known as the V-Force. Its introduction not only represented an extraordinary technological achievement in the development of aircraft and weapons, but also required a massive investment in airfield infrastructure. These aircraft were based at 10 airfields spread across the UK, and all but one were sites that had been constructed before the Second World War. These airfields provided the RAF with pre-existing aircraft hangars and domestic accommodation. The biggest alteration that was required was to increase the length and width of the runways so they could support aircraft weighing 89 tons. One issue of using aircraft which delivered nuclear bombs was that they were vulnerable to being shot down by anti-aircraft weapons. Inspired by the V-2 rockets of the Second World War, both East and West began experimenting with nuclear warheads mounted on rockets. In 1957, the United States of America tested its first intermediate range ballistic missile. As these only had a short range, they had to be based in either Europe or Japan to reach the Soviet Union. The UK was keen to have these missiles, which were known as 4, in the country, and in 1958 it was agreed that 60 missiles would be deployed to 4 main sites and 16 satellite sites. At the centre of each fore emplacement was the launch reactor. The missiles, which were usually stored horizontally on their trailers under retractable sheds, would be raised to a vertical position moments before launch. The fuel which powered the missile were then pumped in at the last minute to prevent spontaneous combustion and the accidental explosion of a missile. As the UK hosted nuclear weapons throughout the Cold War, the Soviet Union developed plans to attack the country. To protect against these airborne threats, the UK developed an air defence system that comprised of detection systems, command and control and communication centres, airborne interceptors, and ground defence. Following the end of the Second World War, the UK undertook an ambitious programme to modernise the country's radar defences, which were known as ROTA. This was to become the most ambitious military engineering project of the early 1950s. The building programme aimed to place the control rooms for the radar in large underground bunkers. These operational blocks were some of the largest constructions built in the UK during the Second World War, and were designed to withstand a 2,000-pound armour-piercing bomb, which was dropped from a height of 26,000 feet. In the late 1950s and early 1960s, studies were conducted into the power of the Soviet H-bomb, and they concluded that early warning systems would not protect the civilian population. Instead, the early warning systems should be used to provide warning of aggression by the Warsaw Pact in order that nuclear-armed aircraft and missiles could be immediately launched. The realignment of defence policy also coincided with a growth in civil air traffic, and Prime Minister Harold Macmillan insisted that any reorganisation of the early warning system should only proceed if it improves civil air traffic control. Eventually, the scheme was approved in February 1961, and the military element became known as linesmen. By 1967, NATO had moved to a strategy of flexible response, in which threats from the Warsaw Pact were to be met by detente, deterrence and defence. A series of reports produced in 1971, at a time when the Soviets were beginning to deploy bombers armed with long-range missiles, outlined the main weaknesses of linesmen, which included its vulnerability attack and poor coverage below 1,000 foot. In October 1971, it was proposed that command should be maintained centrally at two sites located at West Drayton and Strike Command HQ, High Wycombe, which were connected by a digital link to 4 control and reporting centres, which were located around the country. The new network was planned to give full coverage to all the approaches to the UK and to continue operating under hostile attack. Since the 1960s, a number of systems provided the UK with early warning of a ballistic missile attack. One of the main ones was known as the Ballistic Missile Early Warning System. Although developed in the US during the late 1950s, its origins lay in British work to detect the launch of German V-2 rockets during the Second World War. The system consisted of 3 long-range radar sites located at Fur Air Base in Greenland, Clear Air Station in Alaska, and RF Flying Dales in Yorkshire. These fed information back to the computers of a North American Defense Command, which was located deep inside a mountain in Colorado. RF Flying Dales was part of a network of high-powered long-range radar that could give warning of attack by both intermediate range and intercontinental missiles. Depending on the exact launch site, 15 to 30 minutes warning could be given to the eastern states of the US, and 2.5 minutes to 17 minutes to the British Isles and Western Europe. This was intended to give Britain enough warning for the RAF's V-bombers to take off, to activate the Royal Observer Corps' nuclear monitoring organisation, and to allow the United Kingdom Warning and Monitoring Organisation to broadcast attack warnings. To combat the Soviet bombers detected by the UK's early warning system, it was essential that the country had ground defences and airborne interceptors. In post-war Britain, the research and development of guided missiles was considered as important as atomic work and was often in competition for the same high-grade scientists and scarce resources. At first, British defence planners proposed that the new weapons would be used to replace anti-aircraft guns in defence of key sites and regions, and they were initially designed with identical mountings to the guns so they could be installed on pre-existing anti-aircraft sites. As the nature of the threat changed from low-flying aircraft to high-flying jet bombers armed with hydrogen bombs, the system of defence had to be altered. The new anti-aircraft defences had to destroy incoming missiles before they crossed the coast and provide a constant deterrent against surprise attack. To combat this threat, the UK developed a surface-to-air missile which was known as Bloodhound. In addition to the electronic early warning systems developed in the UK, military planners also recognised the importance of visual and audio reporting as a final defence against electronic jamming and low-flying aircraft. The Royal Observer Corps, which was originally formed in 1925 and stood down in 1945, was reinitiated their training in January 1947. And a year later, the organisation were operating 1,420 observation posts around the UK. The problem of providing observers, most of whom were volunteers, with adequate protection against weather was not tackled until 1951, when Monsieur Orlet Limited were contracted to supply prefabricated shelters, which were made in sections for easy transport to often very remote sites. From these structures, which you can see on the screen, volunteers were expected to watch for any sign of Soviet activity. In 1955, the Home Office also realised that if a nuclear strike did occur, it was important to monitor the passage of radioactive fallout. It was decided that the Royal Observer Corps, with its countrywide distribution of posts and communication facilities, was best organisation to undertake this task. In order to monitor nuclear fallout, the Royal Observer Corps needed to be restructured. It was also important that the organisation was provided with new buildings specifically designed to protect its volunteer personnel from the effects of nuclear weapons. Monitoring posts would now need to be constructed underground, as you can see on the slide, and by 1965, 1,518 had been constructed in the UK. It was planned that any information collected by the Royal Observer Corps posts would be sent back to a group headquarters so that the exact position, height and power of a nuclear explosion could be determined. Two basic types of protected headquarters were designed, which included a semi-sunken version on the top right and one which was built above ground in the bottom left. Although the designs differed in external appearance and internal layout, the headquarters contained a standard set of rooms which reflected their identical purposes. If a nuclear attack ever did occur on the UK, plans were developed so that the country's administration could continue. In the early 1950s, these plans centred around a series of protected regional commissioners' offices, which were known as war rooms. The function of the war rooms were to protect the commissioners and their staff, and to collect information on the state of a region following a nuclear attack. In August 1953, just as the concrete of the war rooms was drying, the detonation of the Soviet H-bomb required the Home Office to reappraise their plans. As the Soviet Union now had the power to destroy whole cities and their surrounding infrastructure, it was necessary for the regions to be autonomous for longer. To support the commissioners in their extended roles, a new system of regional seats of government was planned. The function of each regional seat of government was distribute public information, support the police and fire services, and to organise civil defence. With the prospect of the H-bomb, the UK government realised that nowhere in the country would be safe for civilians from a radioactive cloud that would cover the whole nation. By early 1960s, official policy began to emphasise the home as the unit of survival. This was not taken to its logical conclusion, as it was in Switzerland, where every new house had to include a shelter. Instead, the Civil Defence Booklet of the time gave basic advice about creating shelters in different types of houses and staying put until advised to move. Advice that was actually reissued virtually unaltered until the 1980s. In the 1980s, however, more detailed advice was also issued about the construction of domestic shelters, ranging from crude earth and timber bunkers to elaborate purpose-built or off-the-shelf designs. It is hard to assess how many such shelters were built, though advertising leaflets and newspaper cuttings suggest that the doom boom of the early 1980s prompted a growth in construction. And you can see on the slide some photos inside a private nuclear bunker, which is located in Norfolk. It was common during the Cold War for the superpowers to station large military forces in the countries of their allies. In the United Kingdom, units of the United States Air Force were the main foreign military presence. Under President Eisenhower's New Look policy, the US placed more emphasis on the early use of nuclear weapons and massive retaliation should the Soviet Union threaten Western interests. Central to this policy were the aircraft of the United States Air Force Strategic Air Command. However, the Air Force needed bases close to the Soviet Union, since aircraft technology at the time meant that their planes could not cover the distance from the US to the Soviet Union. 1 year after the end of the Second World War, the US and UK began discussing stationing US bombers in the UK, although there was no permanent presence until the Berlin crisis of 1948. After temporary deployments at the Lincolnshire bases of Scampton and Waddington, the United States Air Force had, by 1950, 3 bomb groups which totaled 90 aircraft were based in the east of England at 3 airfields. From 1951, the command of the American Air Force in the UK was split between the 7th Air Division, which was responsible for units allocated to the Strategic Air Command, and the 3rd Air Force, which controlled units committed to a tactical role in Europe. The airfields which were allocated to the 3rd Air Force were mainly facilities that had been abandoned in 1945. Although the aircraft operated by the 3rd Air Force were generally small fighter bombers intended to attack targets in Europe, work was still required to strengthen and lengthen the Second World War air runways so that they could support modern jet aircraft. And you can see one of those airfields which was modernised in the 1950s on the slide at RAF Woodbridge, which is located in Suffolk. By 1958, policy changes, the prospect of new methods of delivering nuclear weapons, which included the long-range B-52 Stratofortress, 4 missiles, and the RAF's V-Force, combined with a decrease in threat of a Soviet preemptive attack, resulted in the US's Strategic Air Command's presence in the UK being scaled down. Under a scheme known as Reflex Alert, far fewer American aircraft were stationed overseas, but those that were had to be kept at a high state of readiness. The early 1960s saw further reductions as the first US intercontinental ballistic missile became operational, and President Kennedy announced further overseas base closures as part of his economic drive. The overall reduction in aircraft numbers was less pronounced in the UK, as in 1966 France withdrew from NATO and a number of American units that had been stationed in France were reallocated to vacant or underused bases in the UK. And you can see on the slide the RAF Greenham Common airfield, and it's something called hard stand-ins, where aircraft were based, and these are specifically designed so that aircraft could rapidly get to the runway and take off in case of an emergency. Archaeological evidence suggests that little new building work took place on American airfields in the UK during the late 1960s and early 1970s. This is probably because the US military was focusing its efforts on the Vietnam War, and relations with the Soviet Union had started to improve. In 1967, Israel's preemptive attack on her neighbouring states' air forces during the Six-Day War had, however, highlighted the vulnerability of aircraft which were parked either in the open or in unprotected shelters. As a result, from the early 1970s, under the Defence Improvement Programme, NATO adopted a policy of constructing protected structures for its frontline squadrons to ensure sufficient forces could survive a preemptive attack to strike back. This marked the beginning of the largest airfield refurbishment programme since the 1950s. Initially, NATO's efforts were directed at hardening essential frontline bases in West Germany. The first airfields in the UK to be provided with hardened facilities were those operated by the American Air Force, as they were able to fund the work. You can see on this slide some of the hardened aircraft hangars that were constructed at RAF Honington in Suffolk. On the 12th of December 1979, NATO ministers took the decision to modernise nuclear forces in Europe, in the European theatre, by deploying Tomahawk cruise missiles and Pershing II missiles. This released aircraft from a tactical role of attacking fixed military targets and freed them to hunt out and destroy mobile Soviet SS-20 missiles. Early in the planning stage, it was decided that RAF Greenham Common, which is located in Berkshire, would act as a temporary site for the ground-launched cruise missile system, while negotiations continued with other NATO partners. By late 1983, construction was sufficiently advanced that the first missiles were ready to be delivered to the site. Besides Greenham Common, it was also planned to deploy 64 ground-launched cruise missiles to RAF Molesworth in Cambridgeshire, which you can see on the right-hand side of this screen. Although work began on 4 shelters, the base was never fully activated, as on the 8th of December 1987, the Intermediate Range Nuclear Forces Treaty was signed between both the United States and the Soviet Union, which eliminated both intermediate and shorter range missiles in Europe. The following year, a 3-year withdrawal period for the cruise missile systems began, and the last missile left Greenham Common in March 1991. There's also been some very interesting work done on the archaeology of the peace camps that developed around RAF Greenham Common. By the mid-1980s, the number of American Air Force facilities in the UK had reached its peak. With the collapse of the Soviet Union, the US began a major reassessment of its forces stationed abroad. The result was a massive reduction in American presence in Europe, which led to many base closures. Today, flying units of the US Air Force are now only concentrated at RAF Lakenheath and RAF Mildenhall, both in Norfolk in the UK. In this lecture, I have briefly explored the impact of politics and technology on the buildings of the Cold War in the UK. I have also hopefully demonstrated that archaeology is not just about digging holes. it is possible to use archaeological techniques to shed light on periods of history as recent as the Cold War. Thank you very much for listening.